The other form of code injection is DLL injection. It is similar concept to shellcode injection, but instead of a shellcode, what we are going to inject is a DLL module, typically a file on a disk, which we want to run inside our target process. So let's say that our dropper is running and our target process is outlook.exe. Now, the DLL is already on a file system, but it can also be dropped by the dropper at runtime, or even dropper can download the DLL from the C2 server and store it on a file system. Okay, that's also possible. So as I said, the process of DLL injection is similar to shellcode injection, and let's go through this process and see how it works. So usually what we do is we allocate an empty buffer in a remote process, but this time it will hold the path to a DLL on disk instead of the DLL itself. Okay, and the reason is that a DLL is a PE file, so it needs to be parsed at loading time by the loader, so the target process can gets the DLL loaded and initialized properly for a future use. There is another technique called reflective DLL injection, which bypasses this kind of restriction. So it allows you to run a DLL inside a process without using a system loader and a file system. But in our case, we are going to talk about classic DLL injection. Okay, so we allocate an empty buffer of a size of at least the length of the path of our DLL from disk. Okay. Then we copy the path to this buffer, and we call LoadLibrary remotely or indirectly. And the way it's done is that we need to locate the address of LoadLibrary in our process, and then we reuse create remote thread with an argument of LoadLibrary and a path to our DLL. Okay, and this create remote thread will create a new thread running LoadLibrary, so it will end up with loading our DLL into the Outlook process. Yeah, now you might wonder why we are using, how we are actually getting this address of LoadLibrary. So one thing what we can do, we can open up outlook.exe process and start to parse it, find the kernel32.dll module loaded in the process. And the kernel32 actually implements the LoadLibrary function. So we open up the process, we go find kernel32, and then we find the LoadLibrary address in that module. Okay, we can do that remotely, but there is another much easier way. Since kernel32 module is loaded in different processes at the same address, okay, so kernel32 in Outlook and kernel32 module in Dropper are at the same addresses, we can actually use getProcAddress function inside Dropper, and we get the address of LoadLibrary, and the same address will be in outlook.exe. Okay, so we can reuse that address in a remote process. And if all goes well, system will load our DLL from disk and initialize it inside outlook.exe. And of course, our DLL has to be specially crafted to start executing our code. Okay. So to summarize the key steps, what we do, we use getProcAddress to get an address to a LoadLibrary inside our process. Then we allocate a buffer in outlook.exe. we copy to that buffer, we copy the path to our DLL on disk, okay? And we call create remote thread with an address of load library we found in step 1 and an argument of path to a DLL which we copied in step 3, sorry, okay? And now I know it all sounds really complicated, but when we jump back to our test VM, you will see how the DLL injection works in practice.